All right, so starting with coefficient matrix. It's a matrix that contains, of course, because I started a video, someone's going to knock. Can someone get the door, please? Contains only the coefficients of the system. Thank you, ma'am. Starting a collection. Just kidding. Those of you that were in the play, if you will sign my thingy before you leave today, please. If you obviously weren't in the play then. Huh?
Stage manager?
Yes, you're on the paper.
I am on the paper.
All right. I enjoyed it. My kid laughed more at me laughing at the play than anything, because he was like, "Why do you think that is so funny?" I was like, "That's hilarious." All right, Cramer's rule. What we've been working to get to. We're going to use the coefficient matrix to solve systems. All right, so we're going to let the capital C be the coefficient matrix. Of the system AX plus BY equal to M, and FX plus GY equal to N. So my coefficient matrix would be just the coefficients of the variables. So A, B, F, G. And the solution to the system, still think about solutions to systems are where two lines do what? Intersect. And so if we're looking for where two lines intersect, we're looking for the X and Y coordinate. So my X is equal to M, B, N, G, divided by the determinant of that matrix divided by the determinant of the coefficient matrix. And Y is equal to the determinant of A, M, F, N divided by the determinant of the coefficient matrix. All of this can work as long as the determinant of the coefficient matrix is not 0. Why can that determinant not be 0? Why can this determinant matrix, coefficient matrix, not have a determinant of 0? Can't divide by 0, so would be undefined. Okay? Questions? Here we go then. Let's do an example. So normally we would do substitution, elimination, something like that, this is a new way to solve the system without dealing with the x's and y's. So we'll start with finding the determinant of our coefficient matrix. And our coefficient matrix will include the coefficients 5, -6, 3, and 4. All right, so how do I find the determinant of this? Yeah, I'm going to use a second order determinant. I agree. How do I do that? Okay, so 5 times 4 is 20 minus -6 times 3 is -18. So that double negative is going to make a positive. So 20 and 18 is 38. So the determinant of my coefficient matrix is 38. I'm going to use that to find my x and y. Okay?
What did you say a double 18?
I'm sorry?
And you did,
5 times 4
yes, and then,
minus -6 times 3.
oh,
Okay? So let's look at x equals. So my x equals, all right, so watch what I'm saying here, and it'll click in a couple of examples, but I want to go ahead and say it. Right here, when I put the m and n in, this is the m and n over here, okay? I'm putting them in position of where the x coefficients were in my coefficient matrix, right? When I'm doing the y, I'm putting the m and n where the y coefficients are. Is everybody with me? Okay. So here I'm going to have 15 and -29 as my m and n. And then I'm going to take the y coefficients, because that's not what I'm looking for right here. And I'm going to divide that by the 38, this number that I just got. All right, so just as a reminder, this is 15 times 4 minus -6 times -29 all over 38. So diagonals and their difference, right? The product of the diagonals subtracted. So 15 times 4 is 60 minus -6 times -29 is 174. 60 times 174 is -114. Divided by 38 will give you -3. So my x is -3. Good so far? Questions?
Never mind.
Okay. I didn't know where the...
am I the only person that haven't done matrix before?
You are, because you weren't here yesterday.
No, but before yesterday?
Not really. Mm-mm.
No, it's first year first.
Yeah. Okay, let's look at the y. So can you tell me what's going in my y matrix? 5,
15,
15,
3,
3,
-29.
-29. Does everybody agree? Okay, and I'm going to divide that by the 38, right? Okay, so products of the diagonals. So 5 times -29 and their difference minus 3 times 15 all divided by 38. So 5 times negative 29 is negative 145. Minus 3 times 15 is 45. And I'm dividing by 38. Negative 145 minus 45 is negative 190 divided by 38, which gives me negative 5.
What happens if it can happen that on the last one it's not like exact
Like a whole number?
yeah.
I haven't run across that at all. I don't think they're giving you anything like that. I'm not saying it can't happen, but I'm saying it'll be a rare
In
case.
the case you have I believe it in fraction or
Yeah, I just need to use fraction. Okay, everybody good? So the last little step here will be to write my point of intersection. What is my point of intersection?
Negative 3,
-3,
negative 5.
-5. So just as if I had solved the system any other way, that's what I get. Questions?
is this a way we have to do it?
For this part, yes.
And what's the question for us to solve it like that? Like what do you have to say? Like there's
Oh, using Cramer's rule. Go ahead, Arlie Beth. I'm sorry.
Can we just plug in the negative 3 back in for the x?
That's such a good question. If they ask you to solve by Cramer's rule, this is what you're doing. So if I'm grading this on a quiz, I'm looking for this. If I'm doing a multiple choice test, I'm plugging it back in. Absolutely. You with me? Does everybody understand what she just asked? She said, if I already have -3, can't I just plug it back into one of these and get the -5? And the answer is yes. But if I'm asking you to solve by Cramer's rule, I'm looking to see, do you understand this part, right? So I want to see this. If you're doing it in terms of a multiple choice test, then I'm not looking for that. Homework, I need to see it because I need to know that you get it. Is everybody with me? Okay. Can you check your work that way though? Sure enough. You can always plug them back in and check. Any other questions? Okay. Let's let you try one then. There you go.